In this lesson, we shall focus on mathematics, MATH141. We shall look at a wide range of problems and we shall solve a wide range of tutorial 11 questions today. And we actually obviously are getting started with our discussion here. Okay, right. So there are a couple of things obviously that we need to take into account here. What are the things that we need to take exactly into account? The things that we need to take exactly into account pertain conics, or what you call conic sections. And in each case, identify the conic section and sketch the curve indicating the vertices, foci, and asymptotes if applicable, etc. Okay, if you look at the, I'm actually obviously indicating that we have already done 2A together with the 2B. But obviously, you note the fact that we did 2A and 2B, yet there was a small little issue with the answer in 2B because okay. Okay, I'm looking at the charts, please. Okay, yeah, okay, you are obviously suggesting that we try to finish it now, then later focus on the complex uh, questions and type 10, number 2 and 3, please. Okay, that's fine. Okay, that's okay. We can always do that. Yeah, but we have time up to 6. We shall push up to 6 because up to 6, at 6 I need to bath. Because after bathing, then I'll have to go to a physical lesson from 8 until 10. I'll be teaching physically. So yeah, if we finish by 6, right, so yeah, we shall see. But yeah, we're saying that to be obviously an issue there, and we sorted it last time. But let us look at number 3. In each case, identify the conic section and sketch the curve indicating the vertices, the foci up together with the asymptotes if applicable. If you look at 9x squared minus 18x plus 4y squared plus 16y equals 11. You see, looking at this, we have the ellipse with center 1 minus 2, vertices 1, 2, etc. Yeah, 1, 1 and that. Okay. Right. So now let us identify this ellipse. We're doing A. So we have actually exactly 9x squared minus 18x plus 4y squared plus 16y. Okay. And therefore have that this is equal to 11. This is equal to 11. Right. So at this point, you then be in a position to then say, you can factor out 9 out of this, getting x squared minus double x. And then you can factor out a 4 out of this, getting y squared plus 4y plus 11. You can complete the square and by getting half of minus 2. You square it, minus the same thing. Right, y squared plus 4y. All right. Which is equal to 11. So you have 9 This is going to be x minus 1, which you close, plus 4y plus 2. Then you have 11. You have 11. Right, let me see. Yeah, that's correct. So obviously this would be fine, but you can see therefore that this is minus 1, but you see if you move it to the other side, it becomes 11 plus. So this is actually exactly minus 1, but if you multiply by the 9, it becomes exactly a minus 9, but if you bring it across, it becomes a 9 plus. This becomes obviously a 2. If you divide 4 by 2, it becomes a 2, which is square, becomes a 4, and you multiply by 9, it becomes a 36, which is 9x minus 1 squared, y plus 2 squared. 11 plus 9 becomes a 20, plus 36 becomes a 56. Becomes exactly 56. Okay, so you have that 56 there. Right, we have exactly the 56 there. Just something to take note of. Right, just something to take note of over there. So we continue with our interpretation. We continue with our interpretation. So obviously, if we have these, the question then is, what exactly do we do now? We identify the rest of the features that we've learned, interpret them correctly, and move to analyze the next stuff. Okay, so obviously I'm pausing because we are reasoning to check if everything is okay here. Right, if everything is okay, then we're able to see what to do next. What exactly to do next in this particular case. Right, in this particular case. Make sure that everything is very correct. Yeah, let's see the charts. Okay. How did you get 9? And yeah, you said how did you get 9 and 39? Okay, these are the things I'm trying to confirm. How we got 9 and 36? Okay, obviously the way we got, oh yeah, the 9 and 36. Okay, the 9 and the 36, because this factorization that it's going to have what? It's going to have the factorization that will have the trinomials. So let's look at the trinomials. So you look at the trinomials from here to there. So this trinomial is going to be what? It's going to be exactly x squared minus 2x plus 1. Then we factorize this, and clearly the factors become x minus 1 squared, all squared. And so next you have y squared plus 4y. But if you take half of 4, you have 2. 2 squared is it's a 4. The factors of this become y plus 2 squared, which is this. But there are these extra things, this one and this one. But half of -2 is -1. You square it, it becomes a 1. But you multiply, it becomes a -1, obviously. You multiply by 9, it becomes -9. You move it across, it becomes 11 plus 9. Even here, you have half of 4, it's 2. 2 squared is a 4. 2 squared is what? It's exactly a 4. So this one must be 4 by 4, which must be 16. I was checking. 4 by 4, which is 16. And then if we add everything, it becomes 20, and then it becomes 36. Okay, now this becomes very nice with the 36. You divide through by what? By 36. And if you divide through by 36, it becomes x minus 1 . All right, so if you divide through by 36, it becomes x minus 1 squared. So if you divide 9 by 36, it becomes a 4. And then you have y plus 2. You divide 4 by 36, it becomes a 9. Okay. So now, check this out. Check this out. Check this out. So now, at this point, okay, so at this point, it's clear that the ellipse we're dealing with, the conic sections we're dealing with is an ellipse. So this is clearly an ellipse. It has center. Right. So we continue. We continue. The center is 1 minus 2. The center is 1 minus 2. Corresponds with this. The description corresponds. Let us deal with the vertices. Right, to deal with the vertices, we'll remember we need to look at the fact that A is always the biggest. So A is bigger than B, always. For the ellipse, first we do it for the ellipse. As we have actually discussed last time. Right, so now, if this actually becomes the case, we then continue as follows. So yeah, we do it for the ellipse, but also we do it for the parabola. Okay, we do it for the parabola. So let's continue. If A is bigger than B, A is always the biggest. So at this point, it means that we're gonna write A squared is equal to 9. B squared equals 4. And this means A is 3, B is 2. If A is the biggest, then now to get the vertices, you consider the fact that the center is this one. If the center is this one, If A is actually the biggest one, it means that the ellipse, it means the measure axis, right? It means that the measure axis is going to be parallel to the y-axis. If the measure axis is part of the y-axis, it means that the ellipse is going to be like this. At this point, it means therefore that the measure axis, right, is parallel to the y-axis. Parallel to the y-axis. Measure axis is parallel to the y-axis. Okay. So now let us ponder to look at these. So if the measure axis is parallel to the y-axis, because the y has a big one, a big 9, and the axis is small, 4, this then means that what we're going to do, we're going to add a and subtract a from the center. We're going to add a and also subtract a from the center. So what then do we do here? Because we have already found the coordinates of the center. Right. Since we have already found the coordinates of the center, what we then do is we add and subtract. So now, if we have the A, right, so it would mean essentially the following. It would mean essentially the following. We take, so now we're dealing with the vertices now. Right, so now the center is this, and then we're going to add A. So if A is 3, right, and we consider the fact that, so you'd be interested in then saying the vertices themselves would be where? So the vertices themselves would have to actually be, one is going to be up, and then the other one is going to be exactly down. Right, so this is what we're going to do, dealing with our translated conics. Translated conics, both the parabola and the and the ellipse. Okay, there's more algebra I want us to do here, of course. There's more algebra that I want us to do here, of course. Right, there's more algebra that I want us to do. Right. 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 We continue. Zina, they've written wrong things here. I'm just posing because I'm just reasoning everything they've written. So the center is correct, but if yeah, okay, possibly correct. Then you're gonna add a 3. Yes, so they fine. Okay, I was thinking otherwise. So you're gonna add a 3 because you add to the y because it's part of the y-axis. So you have 1, 1. So this corresponds. I nearly thought was something else. So the vertices would be 1, 1, 1 minus 2. Then you subtract 3, you subtract A, and then it is minus 5. Yeah, so it's okay. And so now to deal with the foci, say, okay, you remember the C. Now, this is what you remember. You need to remember these so that you don't get confused in the exam. Because here, A is bigger than, here A is bigger than what? Than B. So that C is the square root. Okay, if you look very carefully, our A squared is 9, our B squared is 4. And this is 4. Okay, so check this out. And C becomes the square root of what? Of 5. Okay. And remember that you take the center. So now to get the foci, you take the center. What is the center? Is this one. Because the ellipse is like this, meaning the major axis, right, major axis is parallel to y-axis. Right, so you add, subtract, the square root of 5. Right, you add, subtract the square root of 5. Add, subtract the square root of 5. Right. So that becomes the answer. These become the foci. So it was a good memory for us to remember the ellipse. To remember the ellipse, we did the ellipse a while ago. The hyperbola we have just done recently, so we actually are able to remember the hyperbola. We're able to remember the hyperbola. Right. We're able to remember the hyperbola. Okay. And so now, let us look at the next question. So now we're going to look at 3b. Okay, in view of 3b, we do the same thing. We need to complete the square, etc., and write it in square form. Okay, you see, whenever we have 4x squared minus 9y squared, minus 8x minus 36y minus 68 equals 0. We have precisely the following. So that we have s prime to 3. Right. Okay. Let's continue with this. So we're going to have here, we put the x's together. So 4x squared minus 8x. We group the y's together. Minus 9y squared minus 36y is equal to 68. Yeah. Okay, yeah, we have that. Let us factor out 4. From the first, getting x squared minus double x. Factor out -9. You have y squared plus 4. Okay, you need to complete the square within the parentheses at this point. And to complete the square within the parentheses would have exactly the following. You'd have exactly the following. Let us check this out. Right, let us check this out. We check this out. Right. And then now we check this out. Okay. Now, what exactly then do we do here? What exactly do we do here at this point? So now you'd actually take this and say, complete the square. This will be 4x squared minus 2x. Then you add half of minus 2. We have y squared. Yeah, this is a 4y, please. There's a y here. So this one becomes exactly plus 4y. Plus 1/2 of 4. Completing the square. Minus the same thing. Which is equal to what? 68. Which is x minus 1 9. And then here, this one is going to be y plus 2 is equal to 68. Then you need to move the other things. Like here, this is going to be half of this, half of minus 2, which becomes a minus 1. You square it, it becomes a minus 1. But multiply by 4, it becomes a minus 4. You add it. Okay, half of 4 becomes 2. You square it, becomes 4. So you have minus 4. Okay, this is very important. So we're going to have minus 4, but we multiply it by minus 9. We multiply it by what? By minus 9. Okay, see, if you have minus 4, you multiply it by minus 9, it becomes exactly a 36. It becomes exactly 36. So if it becomes a 36, it becomes like a positive 36, but if you move it on the other side, it will become negative. Okay, let us simplify this. This is 4x minus 1 is squared, y plus 2 squared. You need to add these things. Okay. To make sure we get the correct answers, we can use the cal, but we still can do without the calculator. See, this is the point. It's not a question of the calculator. 68 plus 4 minus 36. All right. $36. You divide by 36. It becomes x minus 1 squared out of 9. You divide 9 divided by 36, it's a 4. Okay. Right. Right. So we continue. We continue. Right. We continue. Now, at this point, you would then say, okay, so what do we do here? What do we do here? What do we do here? Okay, right. Okay, what do we do here? Okay, it's usual. This one is our usual hyperbola. This is the classification, because you need to identify, or it is the identification. Right, so it is our hyperbola. Right, being hyperbola, what is the center? It is center 1 minus 2. But you see, we did the hyperbola recently, but you see, it's not like the ellipse, because we always say the biggest one is actually, or the positive one. This is what we say. We take the positive one. So what then is the positive one? The positive one in this case is what? Is our x. So if the positive one it's the x, then it means that the vertices are gonna be on the x. Right. So are gonna be parallel to the x-axis. So now we have a way to write this one properly. Right. So because the x is positive, we then say the focal axis. This is how we put it. The focal axis. Okay, we write the center also. We can start by writing the center. Okay, let's write the center. So the classification is that we have a hyperbola. with center 1 minus 2 and focal axis parallel to x-axis. Okay. 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 All right. Okay. It is a hyperbola with center 1 and minus 2 and focal axis parallel to the x-axis because x is positive. Because the x has a positive, the y has a negative. Okay, so to x-axis. The formula we use for this one is x minus h squared divided by a squared minus y minus k squared over b squared equals 1. Equals 1. Okay. So now, yeah, we have this. But now I want us to take us to, go back in memory to the conics we learned. Yeah, okay, because the other conics that we learned, but you see the other things we call rotated conics. These conics can be rotated. It's not only that the ellipse is like this and only its measure axis is parallel to the y-axis and the x-axis only. Sometimes it can be like this. I'm sure that you are yet to move to such things. Possibly, yeah, just that this one needs linear algebra. Yes, please.
Sorry for taking you back, Nick. So
Yes,
on
please.
the previous thing, I forgot to ask when
On
I
the
was drawing
previous,
the
this one. Or the other one.
I don't know
Okay,
what
yeah,
I did
yeah,
wrong.
this is our
Yes, I'm
first
going
one.
to ask is okay. Oh my bad. Now I see. Yes, okay. Yeah, yeah. Thank
All
you.
right. Okay, good. Now, we look at this one. And now when you look at this one, there are a couple of things obviously we need to take into account. Right, we're dealing with the hyperbola now, but dealing with the hyperbola, there are a couple of things that obviously we need to take into account. And now it depends on the A we've got. Right, so this is how we write it. So we say, since A is equal to something, this is how we write it. It depends on the A. It's because use this one, the A is the 3, A squared goes with 9. Since A is equal to 3, right, this implies that the vertices, what are the vertices? So now we can alter the center with A, but because we understand that this kind of a parabola, because x is positive, it's going to just be, it's going to be like this and like that, relative to the x-axis. So that it's actually It's focal axis. Focal axis is parallel to the x-axis. Right, so now the vertices themselves are going to be somewhere there. So we change the center, but we understand that the vertices are going to move horizontally. So we're going to have 1, and then we add 3 to it, minus 2, but also we're going to get an answer. So when you say 1 plus 3, 4 minus 2. Okay, then we also have minus 3, which is minus 2 minus 2, which is this. Minus 2, and 4 minus 2, which is 4 minus 2 minus 2 minus 2. Okay, so we found the vertices. How do we find the vertices? We find them from the center using A. What is A? In the case of the, how do we know which one is A here? Okay, so the A is actually what is associated with the positive. The A is what is associated with the positive. Right, so this is very, very important for us. Right, it's extremely, extremely important for us. Always for the hyperbola, we look for what is positive, and that is the A. So the A is going to be 9. Because the A sometimes can come from the Y, because you can have Y minus K squared over A squared minus X minus H squared over B squared equals 1. Obviously, in this case, this is the A. It goes with the Y, because here it's not, the A does not depend on which one is the biggest. In the ellipse, yes, but here the A, because in the ellipse is always B less than A. B less than A always applies in the ellipse. But here it's different. We just choose the positive, we identify the positive, and then whatever is at the bottom is the A, whether big or small. Either bigger or smaller than B squared, doesn't matter. Okay. Now, we have our, okay, something also to remember, and not to confuse this. For the ellipse, it's minus, it's A squared minus B squared, but for the hyperbola, it's plus. So it becomes like A squared plus B squared. Right, for the hyperbola, then this one would give us the foci. Okay, this will give us the foci. So now at this point, we are identifying our A and our B. Okay, so, okay, what is our A squared? So now you see, therefore, that our A squared for the hyperbola is 9, and then our B squared is 4. And this becomes the square root of 13. Yay, we have it. We've got it. We've got it. Now, if you found the C the correct way, but we need to remember that the C has the square root of a sum. And then now we're going to find the foci. To get the foci, we take the center. What did you get the center to be? Right, we got the center to be 1 and minus 2. 1 and minus 2. So obviously it's like 1 and minus 2. So, but because the focal axis, the hyperbola is like this, because the x is positive, it's a positive, and therefore associated with a positive, of course, not just positive. So it means therefore x is gonna be affected. by this. We're going to affect the x component. So if the center is 1 minus 2, it means that it's going to be transformed to 1. Then we add plus or minus the square root of 13 with minus 2. So this one becomes the foci. So that becomes the foci. So it's something we can think about. So this becomes the foci. Okay. We continue. Okay. So we move on. Okay, we've got everything. Okay, yeah, except the asymptotes. Except the asymptotes. Obviously, to get the asymptotes, because in this case, x is the positive one. If x is, I just say x is the positive one because come first now. So I started with the y is the negative. So you'd have x minus 1 squared over 9. Y plus 2 squared over 4. Okay. If x comes first, we've already said that it's going to be y plus 2 equals b over a, of course, with plus or minus x minus 1. So y plus 2, then x minus 1. Okay, we can just easily remember it like this. So the a is always the positive one. The b is going to be the square root of this. So it's going to be plus or minus 2 out of 3, and then x minus 1. But now, in the textbook, and in the exam, you're allowed to write asymptotes like this because this is a textbook. Okay. And then now you come and then say, so you have 0, which is x squared out of 9 equals to y plus 2 squared out of 4. So you have x minus 1. Okay, so you take the square root. Okay, before you even take the square root, you can take the square. Okay, you just equate it to 0. You just change this 1 to 0. Obviously, this works for the hyperbola. So it means that x minus 1 squared and then take the square root. 3 over 2, because if you take the square root of 9 becomes 3, out of 4 becomes 2. Okay, we have taken the square root, but we must make y the subject always. Okay, we don't write, as much as these things are the same, but yeah, I mean, we must make y the subject out of this to get the asymptotes. So it becomes y plus 2, making y the subject, 2/3, like this. And this becomes the answer, which is the asymptotes there. So, but we can always say, if x comes first, then it is what? It is b over a. But if y is positive, then it becomes a over b. That's all. Okay, but of course the plus or minus is always there. All right, so this then is what we have for this particular. Okay, in this case, we're supposed to, in each case, identify the conic section. We've identified it as a hyperbola for the part B. Okay, we've identified it as a hyperbola and sketched a curve indicating the vertices, the foci, and the asymptotes if applicable. Right, if applicable. So we continue. We continue. Right. We continue. We continue. Okay. Right. So we continue. Right. So we continue. Okay. Next question, number 4. Number 4. Okay. So now we deal with this one. Find an equation of the parabola. So we're right back to the parabola we did last time. But now the parabola is traced by, so now just remember the properties of the parabola. So the parabola are 4 of them. There are 4 of them. It's unlike the hyperbola and the ellipse, which are only 2. What do I mean by, okay, because let us revise a little bit the properties of this. So now there is what we call hyperbola. There are 2 of them, but what do I mean by there are 2 equations? So for the hyperbola, overall in this module, we learn more, but obviously mathematics, they are much more than this. But because here we're not studying the rotated conics, because this conics can be rotated in the plane, but that one normally it's done with linear algebra too, because it uses matrices and the angles of rotation and things. But now there's this one where we then say y minus k over a squared minus x minus h squared. Right, so you have x minus h squared, y minus k squared. Okay. All right. So we continue. Okay. The hyperbola is like 2 of the formulas. Then we study also the ellipse. Okay, what do we know about these equations? It's not just equations, but they have specific properties. Okay, we have just recently studied this, so we can remember. This is just about the focal axis, So now we then say that this is the description. We say it has center. Okay, so there's more description, of course. What I want to say is we say the way we describe this hyperbola, we say according to the textbook, it's not according to me. We say hyperbola center, the conic is hyperbola center HK width. Right, width. Width. Right. Width. Or sometimes we use end. So it is a parabola with center HK end. Focal. Focal axis is parallel. Parallel to y-axis. This one becomes a parabola with center with focal axis. Okay, the focal axis is parallel to the y-axis because I normally say the y looks like it has a positive. There's a positive associated with the y and a negative associated with the x. Okay, so now, however, you can remember that, but there's a parabola with center HK and focal axis parallel. Right, because the x is like associated with the positive, so it's parallel to the parallel to x-axis. Parallel to x-axis. Parallel to x-axis. Parallel to x-axis. Okay, yeah, I'm just describing the two equations we learn. For the ellipse, there are also two. Okay, but for the hyperbola, there are many. So now we're going to discuss, there are four of them for the parabola. But for the ellipse, there are also two. What are the equations that pertain to the ellipse? How many equations how many formulas that I was supposed to know? We need to know x minus h squared for the ellipse. But it's x minus h squared, then we have a squared. Y minus k squared over b squared equals 1. B less than a. Y minus right, this is what we have. But you see the tendency for the ellipse, so I'm going to put either we do this one or the other one. So you have y minus, right, right, so you continue. So y minus Okay. I wanted to say we start with x always. Okay, it is the same thing, but according to the textbook, we start with x, but the x now can be divided by b squared. Okay, this is systematic so that you have a way to remember. So that now you have y minus k, and then you square this, you divide by a squared equals 1. And then this one is always b less than a. So the a is always the biggest. So with the ellipse, it's always b less than a. But, okay, what exactly do we note here? What do we take note of? What we take note of is that in the case of the ellipse, because I want us to be able to remember the properties of these so that you don't confuse these things, but you can easily be in a position to identify them in a problem and to be able to recall the correct properties that apply to a given conic section. So now the x minus here you say b less than a. B less than, so if b is less than a, this one is the measure axis. This would be the measure axis. So here a is always the biggest, but sometimes the biggest one is under x, sometimes the biggest one is under the y term. Okay, but here for this one we then say the measure axis. Measure axis parallel to, because here the x associated with the biggest one parallel to x-axis. Here the measure axis parallel to y-axis. Measure axis parallel to y-axis. Measure axis parallel to, because the y is having the biggest a, so the measure axis is parallel to y-axis. Here the measure axis is parallel to the x-axis, because x is associated with the biggest one, is the numerator of the biggest a. Of course, the center. The center is HK. Okay, I'm looking at how the textbook classifies these things, please. This is the textbook classification. Anton. I'm also looking at Anton as I'm discussing with you now, to make sure that everything is aligned with Anton, because the tabs are from Anton, but the center is HK. Okay. Now we come to the biggest discussion. The four conics. We come to the biggest discussion about the four conics. The four conics. Okay, we studied them in 2 classes. Okay, we say parabolas. Parabolas according to Anton, not according to me. So we're going to classify this with simplicity. Parabolas with the vertex. By Anton, I mean the textbook. Okay, you can be like, okay, but who is Anton? It's the textbook prescribed for you guys. I sent you the copy last time. So now, parabolas with vertex, HK, and axis parallel to x-axis. Which is y minus k squared for p x minus h. And then we write here opens right. Opens right. Opens right. Right. Okay. Okay, now there's another one. There's also y minus k. Sometimes there's a negative in front here. There's a minus 4p. And then you have x minus h. Opens left. Parabolas with vertex. And x's parallel to y-axis. X minus h. Y minus k. X minus h. Minus 4p y minus k. Opens up. And then opens down. Okay. These are the 4 parabolas. These are the 4 of them. These are the 4 of them. Okay, I want us to just take a deep breath, reflect on this, and like try to internalize them. It's not about just having these formulas, but remembering them. So you can have the y minus k all squared, but then we have 4px minus h. But because, so you look at it in terms of the cardinal axis, somebody calls it the cardinal pillars. So here, there's sort of a positive in front. You can imagine it like that. The y squared is sort of a positive. The 4p is like positive because the p is positive all the time. So now, because of that, then you can see that the x is what? The x is positive. So this kind of a graph is going to open. It's going to open right because x is positive here. What about this one? If x is negative, okay, here x is positive. If x is negative, then this one is going to open left. Okay, so this is for the x's. This is for the y's. The y's. But if y is positive, it opens up. Y is negative, it opens down. Okay. Okay, now we are right back, and then we have everything. We're trying to remember the properties of these shapes. We're trying to remember the properties of these shapes. Let's not waste the whole day on the properties. Let us tackle the question. Find an equation of the parabola traced by a point that moves. Okay, that's very interesting. It's traced by a point that moves so that the distance from 3 and 6 is the same as its distance to the axis. Right. Its distance to the x-axis. This is more like we need to picture it because there's some movements here. And with the movements, you see, we don't describe things in terms of the movements. Most of the time, we actually describe things in terms of the directrix, the vertex, the focus, and so on. Okay. Find an equation of the parabola traced by point that moves so that its distance from 3 and 6, there is a point apart where x is 3 and y is 6. Three and 6. Right. So if 3 and 6, it is exactly the same as what? Okay. All right. So now we continue, please. So if this is the case, then we think about what we need to do here. We think about exactly what we need to do here. We think about what we need to do here. All right. You think about what we need to do here. Okay. Let's analyze this together, please. Find an equation of the parabola traced by point that moves so that its distance from 3 and 6 point that moves so that its distance from 3 and 6 is the same as its distance to the x-axis. Right, and its distance from the x-axis is what? It's exactly 3, 6 units, 6 units. Okay, because how high we go, how high you go. So we go up to y, so it's 6 units. That is the distance. Okay, so find an equation of the parabola traced by a point that moves so that its distance from 3 and 6 is the same as its distance to the x-axis. Okay, there's more. Okay, I want us to reflect on the statement here. Because when they're saying you need to find an equation of the parabola traced, the parabola is traced by point that moves so that its distance from 3 and 6, there's a point whose distance from 3 and 6 is the same as the point's distance from the x-axis. So there's another point whose distance from the point 3 and 6 is the same as the point's distance from the x-axis. Okay. This describes the focus. This describes what we call the focus. The focus is the sort of point that we're talking about here, but there's more. There's more that right. Right. So we continue. We continue. We continue. Right. Right. We continue. We continue. Okay, y'all. Okay. Okay, there's more I want us to discuss about this. There's more I want us to discuss about these. Right. There's more I want us to discuss about this. So this says there's a point that moves. So this is how we describe a parabola. And then we are done, please. This is how we describe a parabola in general. If this one is the focus, we describe a point that moves. This point that moves, if the parabola is like this, we describe a point that moves and you call it an arbitrary point, P. And then we have the directrix. We have the directrix. We describe a point that moves, and here's the point that moves. So this point is what is tracing the shape. But we describe it in terms of the distance. Its distance is measured from the focus. And this point moves and it traces this. So find an equation of the parabola traced by a point that moves so that its distance. So let me lower this a little bit down. I want to draw, to run over the words. Okay, so yeah, this is just a rough sketch of the rule we use. We look at 3, 6. 3 and 6. Find an equation of the parabola traced by a point that moves so that its distance from 3 and 6 is exactly the same. Yeah. As its distance to the x-axis. Right. So now we actually obviously would be interested in looking at how we can actually obviously deal with this. But a couple of things that we need to remember. We need to remember these specific rules. And think about the direction in which the whole thing opens. Does it open right? Does it open left? Does it open up? Does it open up and down? And therefore, the rest of these. So if we then look at that and then say, what then we have as the 3, 6 gives us the a focus or a point related to the focus at least, or a cousin point to the focus, if one likes to say. So you then say, for instance, you then actually have an x minus 3, and then you would have a 4p, and then what would be the, you have the 4p and you have the y minus what? If it's y minus a certain number, what number would that be? So these are the things you actually think about. We suppose that it is x minus h squared 4py minus k. It's the formula that we can select. Right, and now if the formula that we can select, as indicated here, this one opens up. So we therefore assume that therefore these will certainly open up. Okay. These will surely open up. So then if it opens up, you'd have a variety of possible shapes. Right, you'd have a variety of possible shapes. You then say, this will be its possible shape. But let us ponder and reason this out, because it's the same notion as this. Right, then now, if this is the point, and we assume once again it's the focal point. So that is being described. But now the question is obviously being given the focal point. What does the focal point give us? So the focal point would give us, would be associated with an axis that runs through the middle. But from it, we shall be able to find the vertex. What would the vertex be? Right, so it would be that the x of the vertex is 3, and then the y is the midpoint. If this runs up to 6 to the focal point, then the midpoint for the vertex is going to be a 3. It's going to be exactly a 3. Right, so there's more I want to say here. There is more I want to say. There is certainly more I want to say. If we assume this is a vertex, of course we will say much more. You then have that x minus 3 squared 4py minus 3. Right. So the question, therefore, is what is the P? The P, therefore, is going to be the distance here, the distance there. This would be the directrix. What would the distance be? Okay. So, okay. So we are measuring 3 units. 3 units. So that P becomes 3, and therefore X minus 3 squared is 4 times 3, and Y minus 3, and therefore X minus 3 squared, 4 by 3 is 12, Y minus 3. And this is the answer. Any question about this? So which means therefore we have the Y is equal to 0 on this axis here. Y is equal to exactly 0 there. From 0 to 6, right? Okay, at this point is 3, 3 to 3, 6, then is 3, 0. 3, 3 is the vertex. And then we interpret the fact that we need to find the equation of the parabola traced by a point that moves, so that its distance from the 3, 6 is a point that moves. So we can put the point somewhere here. Call it X and Y. We are measuring the distance from 3, 6 is the same as its distance from the x-axis. So this point is going to come here. Its distance from this point, and then it moves here, is the same as its distance from the x-axis. Its distance from the x-axis. By the time it gets here, its distance from the point is going to be the same as its distance from the x-axis. So this point is going to be in the middle here. It's going to be in the middle there. But in the middle, it describes the vertex for us. It describes the vertex. Okay, so that is the answer. That is the answer. Yeah, we're gonna take a break, please. I'm supposed to go and teach physically and think about this question. Very interesting one, but there's a lot you can pick from this. It's a very, very interesting question. So I'm just thinking about these. Just thinking about these. Just thinking about these. Okay, in line with this, just before we stop, generally we call this point P and then we call this one. So we then say we call this one P, D is this one. And then we come and then say PF, the distance between P and F. We find the distance. What is the distance by the distance formula between P and F? It's going to be X minus P by the distance formula squared and then Y squared. Then we find another distance between P and D. And then we have the distance between P and D is x plus P squared, and then 0 squared, the y and the y. Right, so if we then say the distance of this point, the point P, it's moving. But by moving it, tracing the shape. And so we're then saying, using the words of the examiner, to say its distance from 3, 6, which is its distance from what we call the focus. Its distance from the focus is the same as its distance to the x-axis. So if it's here, the distance from the focus is the same as this distance. So E is the midpoint. The midpoint. So as a consequence, this point is going to be, okay, the distance from of P to F is the same as the distance to these directrix. The same as the distance to directrix. So we then say PF is equal to PD. Which is x plus P. Okay. You simplify everything, which means y squared is equal to 4px. Okay, if you square everything here, it becomes y squared is equal to 4px. For example, for this kind of a shape. So even here, one way to do this question is to do the following, which is nicer. It's not the only way to do it in red. So you're going to do it in short in blue. We're going to say the distance of this point. Find an equation of the parabola traced by a point that moves so that its distance from 3, 6. Here is the point xy. Its distance from 3, 6 is the same as its distance to the x-axis. The distance of the point to the x-axis, what is the x-axis? The x-axis would have x, a coordinate, and then y is 0. Y is 0. So which means that the distance you can use a formula here. Okay, you can say if this point is F, P, and this one is called D for the directrix, then you can find the distance between P and F. So you can say PF is the same as PD. Okay, you can write some steps like this. And then what is PF? It's x minus 3 squared, then you do y minus 6 squared is equal to, then its distance from the x-axis. So the x and the x minus x is going to be 0, giving us only y squared. Okay, obviously the distances are equal, so you have square roots there, but we square both sides. And if we do, you would have exactly that. Okay, like we have done here, so it's going to be x minus 3 squared which is equal to y squared. Okay, you square both sides here. Okay, if you square both sides, x squared minus 6x plus 9 plus y squared okay, I'm going to do it in green color. Okay. The y squared is going to like cancel. If the y squared is going to cancel, it's going to give us the answers. So you're going to have x squared minus 6x, the 9 and the 36 is going to give us a 45 minus 12y. Let us look at this. Okay. So you can do it like that. You can say the distance to the point is the same distance to the x-axis, yeah? Okay, I know it's congested here, but I'm trying to make sure that you can see everything we played with to get the answer. So which means that you're going to have x squared minus 6x, and then we add a 9. We perform a split. So if we split 36, it's going to be 12y minus 36. X minus 3 squared, 12 into y minus 3. Okay, I just wanted to make sure that we just have everything we can see we've done. So obviously it becomes the same answer. So you can just use the fact that, okay, find the equation of the parabola traced by point. Okay, assume that you don't even know the formulas, and then say there's a point whose distance from the 3, 6 is the same as its distance from the x-axis. The x-axis, you can, the point there, you can take x0, and then you're able to simplify, and you get the same answer that we can get using our things, our formulas in this section. Okay, I'm hoping that we can do a little bit more practice questions like this. But yeah, but this is enough for the morning because I need to actually run to a physical lesson in class. But I must thank you for joining us this morning. I'm going to send the recording. Yeah, but now obviously, yeah, I'm running now to teach physically. What time we are going to meet again? Let me see. I'm going to notify you either by 12, around 12, or either around 12 or around 2, 12 or 2, or both. Okay, so yeah, I will send you a notification there, but you can continue. Right, so yeah, thank you so much for joining us this morning. I'm gonna send the recording, but now I'm running to teach. I just have a meeting from 8 until 10, and then I'm gonna be right back after 10. So yeah, I can only be in a position to log in and communicate in the neighborhood of 12 so that I can do something and we see what to do. Okay, thank you for joining us right now. Until I'm gonna notify you of the correct time, because I don't want to make mistakes. I don't want to give you empty promises of time that is not gonna work, that I'm not gonna be able to keep. I don't want that. Right. So yeah, I'm gonna send you the time. But thanks again for joining us. We shall meet again, obviously, in the afternoon. I'm gonna send you the notification of time. But thanks then. Take care. Goodbye, and enjoy your morning. Goodbye.